Hello, everyone, and welcome to our third episode in our Linux series. Today, we're going to be going over device configuration and management. Now, in particular, before we get started, you may notice some differences in this episode, such as that I have Ubuntu Desktop loaded, and we're actually going to be using that today. So, I actually have a specific reason why I chose not to use WSL2, and that's because with certain virtualization software, you're unable to see the full device configuration on your system. So with VirtualBox, which is free, and this Ubuntu desktop software, which is free, I set up a virtual machine and I did some configurations so we can see how these commands work in a better fashion that's more transparent. So let's go ahead. We're going to get started today. We're just going to open up the terminal. So here we are. And like I mentioned prior, if you're using Windows Subsystem for Linux, or even if you create a virtual machine, you might not be able to see the full hardware available on your system like you would if you had downloaded the OS and booted it directly from your system. And that's because the virtualization software abstracts away some of the hardware and it makes it where instead it's more integrated. And I'll point out some things as we're looking and using these new commands to learn about our devices. And I'll show you what I mean. So let's go ahead and get started. We're going to jump right into it. So you could follow along from your terminal, and I'm going to describe some of the things that we got going on. So the first command we're going to be going over is ls usb. Now, just like ls, which is the command that lists the files in the current directory, ls usb also lists something, but it lists the USB devices that are connected onto our machine. Let's go ahead and use manual on ls USB to learn a little bit more about it before we use it. So manual ls USB. Now we can see some information. So as we said, it lists the USB devices, and it says that it's a utility that displays information about the system and the devices connected to it through USB. Now, it also mentions something else here called UDEV. That's the background service where, for example, if you plug in something in your USB port, you don't manually configure it each time. UDEV is the background service that automatically configures it for you, so you just plug it in and it works. And this is how it goes most of the time. And you could also see we got some parameters, we have the verbose parameter. You can look up the USB device by the vendor and the product ID, which could be like, it could be Intel and like a graphics processing unit, which in this case would have to be through the USB. That's typically through PCI, and we're going to be going over another command later that goes over the PCI devices. But let's go ahead and hit Q here to exit, and we're going to use ls USB. And like we said, this is going to list the USB devices connected to our system. Now let's give it a try. As you can see, we have some output. So some of the output that we have, like Linux Foundation 2.0 and 3.0, you might be seeing that regardless of what distribution you're running, as well as some software, because that's just like Linux software. We see some other things too, like we see this VirtualBox USB tablet. We see a Razer device. Then we see a keyboard. So I'm going to go over these things explicitly, And if you're doing this through the Windows Subsystem for Linux, or if you're following along in VirtualBox and you booted a virtual machine, you may not see anything except the Linux Foundation USB devices and the VirtualBox device. And that's because when you're using virtualization, the software integrates your hardware into the application, which in this case is VirtualBox. There's like an abstraction away from the hardware, so we can't see the hardware. And if you use this command, you probably won't see these two options. Now, I went in the VirtualBox settings and manually adjusted it where it registered my USB devices, and that's why we see it here. So usually we wouldn't see these devices if you're using virtualization software, but if you have Linux and you're just booting from your local system, you should see everything. Like if you had a laptop, you could probably see like an integrated camera. You could see integrated touchpad. Maybe if you can touch your screen and use it as a touchpad. But here we see a keyboard and we see this Razer Barracuda X, which is actually a headset that I have. So I manually entered these in the VirtualBox configuration so we could see them here. And this is what I'm trying to demonstrate. My keyboard is connected through a USB port. And my headset actually uses Bluetooth to connect, but it also has a dongle that's plugged into the USB. And that dongle is what uses Bluetooth to connect to my headset. So it does connect through USB, and it uses a Bluetooth adapter in order to connect. So, if you had, for example, right now, I have my Logi camera, which has HD 1080p quality. If I had that plugged into my system and I booted Linux from my local machine as the original operating system, we'd probably see that here. But because it's virtualization software, it's not included in this list. And actually the things that are included, I had to manually input. So this is another reason why I'm running this virtual software today in this manner, because if you use Windows Subsystem for Linux, you may not be able to have the hardware come up that you might use this command and only see the three options and not these two. And that would be because the abstraction away through the virtualization. Now, we'll also look at some of the other commands. We have ls usb -v, verbose, so we could see some more information about the USB devices that are connected on our machine. Let's give it a try. And as you can see, we get a lot of output here. But let's see, if I scroll up, we can see some information here. Let's go up a little more. So if we go here, we could see this is the Razer Barracuda X. Now, if you looked up Razer Barracuda X on a web browser, you probably see a headset, a wireless headset, and that's what I have. That's what this is. So I registered it in VirtualBox, and that's why it's coming up. It says couldn't open device. Some information will be missing. Now that could be because that I don't have maybe all the full configuration for it, or also it's off right now. I'm not actively using it. So that could impact some of the results that we see here. If you scroll down, you could see ID vendor, ID product. So like if you were filtering through your devices, you could use this vendor ID and this product ID in order to search it directly. We could go down and it gives a lot of information. We're not going to be going over all this today, but you could copy paste this into maybe Bing AI or ChatGPT, and it would give you some more information. But I will say, you could see some certain things here, like audio, control device. We know it's an auditory device. It says microphone. It does have a microphone attached to the device. USB streaming, it's plugged in through USB. Just some information about it. It's an auditory device and it gives us the ability, I have a microphone with it, it's through the USB. So you can see some interesting information here that gives you some more details about, your hardware. Now let's go ahead and clear this window out. And we're going to be going over another command, which is ls PCI. Now, PCI stands for Peripheral Component Interconnect. And typically, this PCI device could be a GPU, like a graphics card, graphics processing unit. Could be, an expansion card, like maybe you have some other thing that you're using. And we're going to go ahead and take a look at it. So let's use the manual command on lspci to learn more about it. So we can see it lists all PCI devices. It's a utility that displays the information about the PCI buses and the devices connected to them. Now you may notice they use the term PCI buses, USB buses. So if you have a laptop, for example, and you have an integrated camera, it's still going to be connected to your USB bus. Even if it's integrated, it's using the USB host controller in order to be used. And these controllers and these buses these are technical terms in order to describe how the motherboard, or sometimes the chipset, which has to do with your CPU, these things can contain circuitry that enables you to communicate with these devices. So, the USB host controller on your motherboard, or sometimes it's integrated into your CPU or your chipset. The terms kind of used loosely, CPU and chipset. Your CPU could determine your chipset, and the chipset could have things like the USB host controller, an integrated graphics processing unit. Now, these things could also just be on the motherboard. The USB host controller can be a chip on the motherboard. But this is all very technical. I'm just trying to help you get a better understanding that, you know, your motherboard and chipset contain these controllers that enable you to connect hardware through USB, through PCI. And through these connections, we have actually something like a driver, if you're familiar with that, or in this case, it would be a kernel module. And basically, this is just software that lets your system interact with these devices. So, you could scroll down here and we'll see some more stuff. You could see it has the minus a B option for verbose, and has some other options, and even mentions here kernel drivers. And as we mentioned, a driver is the software that the hardware can use to communicate with the operating system. So, like if, you know, basically if you have a device that's connected to your system, it uses the driver or the kernel module, and it uses that software from the driver or the kernel module in order to interact with the system. And this is also known as a hardware abstraction layer, which essentially just means when you hook up a device, you don't need to know all the internals about the software, the hardware, the way it works. It just works for you. And that's what the kernel modules do. That's what the drivers do. And we're going to go ahead and take a look here. We're going to hit Q to exit this. We're going to use LSPCI to see what PCI devices we have connected to our machines. So let's go ahead and try it out. And you can see we got some information. Now the host bridge is typically your chipset or your CPU. So, and actually something I would like to mention here is if you have, for example, an AMD processor, it could have compatible drivers with another CPU. And here you might not see the actual name for your CPU. It might be another driver with a different name, but some of the kernel modules or drivers are compatible with each other. So it may give you a different name, and that could be a bad thing, but usually it just means that it's compatible with other devices. So they use the same driver for multiple devices since they're compatible with each other. We can see some other things. We have the VGA compatible controller. It mentions VMware. I'd assume that's because I'm using this as a virtual machine, and we could see that this desktop is being displayed in this video. But for me, I have my Windows open, and this is actually a window on my monitor that's in my Windows operating system. I'm using virtualization software, so it comes up in its own window, like an application almost. And it mentions the Ethernet controller. Without the Ethernet controller, we wouldn't be able to use our NIC or our network interface card. And this is how we connect to things, on the network. It allows us to plug in our Ethernet cord, and that's how we get our internet connection. It's through the NIC, and the Ethernet controller assists the NIC in almost as like it assists it in terms of, if you have the right drivers and your NIC card, you're able to connect through the internet and do other things. We got the audio controller. We got, this may be an integrated audio controller in our chipset. And it even mentions down here chipset. And if we look, it's a USB controller. So, I do have a 7 series Intel CPU. And through this series, in the chipset, we have the USB controller, which is almost like I mentioned, like how the USB root controller could be a chip on your motherboard, but it also might be integrated into your CPU. And this could also be the same for a graphics processing unit. So let me throw a hypothetical at you so you could better understand what this could be used for. If you use LSPCI, and let's say you have a graphics card, if it's not showing up, it may not be properly connected, or there might be some other issue. Like maybe if it's not showing up right, you need to download the drivers still, because maybe the drivers, you need them to configure the device properly. And you could see, for example, if you had an NVIDIA GPU, you might need to download the drivers for that GPU in order for it to come up here. So these commands are useful to see what devices are being registered by your system, and also to learn more information about them. I'll give another example. If you have a warranty on your desktop computer and you don't know about all the hardware inside and you just want to find out real quick, you could type LSUSB or LSPCI. For the same with the laptop. If you can't open up the laptop, you could use these commands to find out about the hardware inside of them and maybe get the right driver for that hardware, or figure out how to properly configure it. And these drivers you'd usually get from the manufacturer website. So if you had an Acer camera, you could go to the Acer website, download the drivers if it's not working properly. And these drivers should enable you to use the devices that are connected to your system. As we mentioned, we have LS-USB, which is for USB devices. And if you have, certain devices plugged in, like right here, as we saw before, we saw the keyboard. Let's go ahead and clear this up. LS-USB. We see the headset and the keyboard. Those are both connected through USB. Then we have LS-PCI. This mentions some stuff about VirtualBox. Like, I don't know what this service is right here, but I'm using VirtualBox in order to host this virtual machine. I'm assuming that this is some abstract service that takes advantage of some of my hardware, and it does this through the VirtualBox. And we got other things going on here, like the audio controller, SATA controller, for your hard drive and everything. So definitely some useful information. As it says Intel 7 series right here, I have a Series 7 CPU, so you could find out all sorts of stuff about your system and the items that are connected to it. Like in PCI, like we mentioned, it could be an expansion card, it could be your GPU, etc. So let's go ahead and clear this up. And I know we've been mentioning a lot about the modules. So there's actually a way to view what modules are on your system. And that's through the ls-mod command. Just like LSUSB and LSPCI, it lists something for you, and in this case it's the modules. And let's go ahead and use manual ls-mod here to learn more about the ls-mod command. And as you can see, actually, if you go all the way down, this is all the content in the manual. So it does say it shows the status of modules in the Linux kernel, and it says that it nicely formats the contents of this directory, and this directory is where your modules are registered. So let's go ahead and quit this real quick, and let's use ls-mod h for help. And I'm actually trying to show you something here. This command really is just used to list the modules on your system. There isn't a lot more that it's used for, so let's go ahead and give it a try. We'll do ls-mod. We see a lot of things come up. If I scroll up all the way to the top, we can see the name of the module, the size of it, and what it's used by. So let me go ahead and scroll down here. SND is actually the sound module. And we can see this is the module for USB connection. And it says audio, but we can tell it's sound from the SND. And then if we look at these modules are currently using that module right here. So modules rely on each other in order to properly configure hardware devices that are plugged in. So like we mentioned, this is the hardware abstraction layer. We don't necessarily have to write each module every time you plug in, a different camera, a different mouse, etc. But these modules enable you to just plug in devices. And one of the main reasons we're going over this today is, regardless of the distribution you use, if you're using some cutting edge technology, RAID configurations, etc., you may need to configure it properly on your system. And in order to configure it properly, you need to know how to navigate like LSUSB, LSPCI, LSMod to know what modules you have, and you might need to install more modules if you don't have the right ones to for the configurations on the hardware you're using. Like I said, cutting edge hardware, it's different than Microsoft or Mac OS, where in Windows, it's proprietary software. So typically, drivers are made for those devices. But in Linux, drivers are still made for Linux, but typically it's made for Ubuntu or Red Hat. And sometimes it takes some time for them to come out when if you get the newest graphics, the newest GPU, the newest graphics card, it may not even have a driver available yet. And sometimes that needs to be worked on. And then when they do release it, it could be for Ubuntu or Red Hat typically. If you're using Ubuntu or Red Hat drivers, you need to check your distribution and see which of those drivers are compatible. Because, for example, they don't release drivers for Kali or CentOS always. Sometimes it's just Ubuntu or Red Hat. But usually the other distributions are able to download those drivers. It enables you to use the same ones, but it depends on which distribution you're running. And you're going to want to check the documentation to ensure, okay, this distribution uses the Ubuntu package. I can use the Ubuntu package on this distribution. Stuff like that. We see some other things, like it mentioned sound again. If we scroll down, it says video. So this is like the video module. We can see that it's in use by this module right here. I'm unsure what that is, but the modules, like we mentioned, they would depend on each other, and they enable you, in this case, to get video, to use your graphics processing unit. So let's go ahead and hit clear here. And now I'd like to go over something with you guys today. So what we're going to be going over is the device folder. And this list of device is that, the device files that are special on your system. So let's go ahead and take a look. So we're going to change a directory into the root directory, ls. We can see right here, dev. Now that is for the devices on your system. Let's go ahead and change directory into the device folder. Now if I do ls here, you can see that we have special device files. And this is, these can be the files that interact with the devices. These are like the device interface files. So your system interacts with the devices through these files at times. So we got USB, we got CPU, we have disk, FD for floppy disk. If you scroll down, SDA, that's your hard drive. That's the first hard drive registered by your operating system. So and here we see sound, SND. So these are the special files on your operating system that interface with the hardware. Now, I actually would like to go over something with you guys today, and that's a blacklisting kernel modules. And this has use if, for example, let's say you wanted to blacklist Bluetooth because sometimes it's a security concern, or if you wanted to blacklist sound because you just don't want your system to be compatible with sound, you don't want it to play any sound. There's a special folder that we can go into that allows us to do that. So let's go ahead, we're going to change directory. We're going to change directory into the root folder, and then we're going to change into the etc folder. And we're going to go over more of this folder in another episode, but for now I'm just trying to show you where you could go to blacklist specific modules. And we're going to change directory once again. Actually, let me list this first. Alrighty, so we're going to change directory. Oh yeah, it's the mod probe directory. Let's see, mod probe D maybe. Alright, let me see if I can find it right quick. Alright, so it looks like I actually just misspelled it. Let's actually try again. We're going to do change directory mod probe with an E, D. And here we are. So there's that special service UDEV, which registers devices for us in the background. So you don't have to register every single device as you're using it. If you plug it in, it should just work. And this is also relatively new. If you're using like legacy software or hardware, you may need to get the drivers that we've talked about. And in this case, mod probe is, this probes your modules. So let's go ahead and list this directory. I'm not going to get super into this directory, but let me show you right here. It says blacklist.conf, which is configuration. And I would recommend creating a backup of this file in case you do edit it. But let's go ahead and read the contents of this file. Alright, and as you can see, if you wanted to blacklist a particular module, you would just type blacklist, and then you would type the name of the module, which in this case, that looks like hexadecimal. And here it says ETH, that's usually Ethernet. You know, I don't know what 1394 is, but it says causes no end of confusion by creating unexpected network interfaces. Now, I don't know what that module is, but clearly they've disabled it for a good reason. And you know, they have some other ones. As you scroll down, you can look through these. So if you really wanted to disable a module, whether it's the sound or Bluetooth, you can figure out which module it is, go in this folder and blacklist it. Because UDEV by default will load, you know, the modules, and since it does it by default and it does all this configuration for you, you know, it may, like for example, you could, I think, disable a driver, but then when you turn your operating system, when you turn your machine off and turn it back on, it's just going to reload it. So you could blacklist it, which by default, when the kernel loads, it's going to blacklist those modules so they're unable to be used. Now, I've been promising for, you know, the past 2 episodes, I was going to show you guys a bash script. So we're going to take a little bit of what we learned today, and I'm going to show you how to create a script, and we're going to be using the bash shell. So let's go ahead and clear. And we're going to change directory into, let's see, we're going to go into our root folder, do ls. You know what? No, I want to go to the user folder. This is a good idea for you if you're making documents and stuff or scripts. I'm going to use ls. You can see there's a documents folder. That's a good place to store documents, right? So let's go ahead and change into that directory. Like I mentioned, a lot of these modules and such, you know, they may have different names. Honestly, I wouldn't mess with any of these names. You can change the name of modules and devices, but just know if you change it on your current machine, it may not be the same across all other machines, and it could even cause you some confusion if on one machine you have Ethernet named one thing, on the other it's named something else. And likewise with the modules and the devices, sometimes it registers as a differently named device, you know, so it's honestly, it could be a little confusing, but you know, I'm going to show you how to take advantage of the commands we've gone over today and put them in a script. And we're actually going to be using a special symbol. This is the greater than symbol, and it basically is a redirect, and it redirects the output to a file. So let me show you what I mean. We could do echo, which this is a new command I'm showing you guys right now. We're going to be using this in the script, so I wanted to show you its functionality. Say echo hello, and look at that. So echo, all it does is it prints some text to the terminal, and here we printed hello to the terminal. Now let me clear up this window, and I'm going to show you how to create a script using nano. We've gone over nano a little bit prior, so we'll do nano device script dot shell, and we want to use this so we can emphasize that it's a shell file. And as you see, it's going to create this file in our current directory because there's no path, it's just the name of the file. Before we do, let me show you, there's nothing in this directory, so let's go ahead. We'll do nano device script dot shell. Alright, and when you're starting with a bash script, you're going to want to declare what binary it's using. And in this case, in this script, we're using the bash binary. So let me show you what I mean. Say declaring the binary, which we're declaring which shell it's using. You know, this could be Z shell, could be like, you know, I mean, there's PowerShell. PowerShell's cross-platform. You would declare at the start of the file the shell you're using. And in this case, I'm declaring the shell. And if you see here, this pound sign, this is going to be a comment. So in our scripts, this is not going to come up once we run our script. This is simply if you want to go back to your script and you're reading through it, Comments are very good for helping you understand what exactly is going on in your script and what each step is doing. So in this step, we're declaring the shell that we're using. Declaring the shell that we are using. Alright? And so when you're declaring the shell, you use a special set of characters. They're called the shebang characters. So we're going to go ahead and do that. And these are the characters. So notice how it has that pound sign or the hashtag. So if you use it in this way with the exclamation point after, you're actually declaring which binary you're using. And in this case, because we're using the bash shell or the program is actually in your binary folder in your system. So we'll do bin/bash. And this is what we're doing. This shebang is being used to declare that we're using bash in our binaries directory. And binaries is just, a folder that has utilities and programs that we can use. And bash resides there. So a single pound sign is for a comment. And this is a special set of characters that declares the shell we're using. So now that we have gone over that first aspect, now we're going to go create our script. As simple as that. We can use commands that we use in the command line. So like if we did ls usb, if we saved this script right now and ran this script, it would run this command for us. But let me show you exactly. We're going to create a script that's useful. And don't worry if this is a little confusing. We're going to be going more over bash shell scripting in more episodes. But this is just to introduce you to it. So let's go ahead and we're going to do a comment. We're going to say we're listing the USB devices in our system. And with this, we'd be using the ls usb command. Now, if we type it just like this, it would just print to the terminal. But that's kind of a lot of text, especially if we're going to be doing, we'll do this too, we're listing the PCI devices in our system. Or it should be connected to our system. But this works too. We'll do ls PCI. Now, if we ran this script just like this, it's going to print both these commands to the terminal, and that's going to be a lot of output. You might want to help clean up the terminal, so instead maybe, and that's where that redirect symbol comes in, and if you want to move throughout the lines in this file with Nano, you could hit the up and down keys on your keyboard, which is what I'm about to do. And since it's only printing the output from these commands, let's print our own output so we could say what's happening in the background. And this is nice because when you're running your own scripts, you might want to know what's going on in the background. So let's do echo, and we'll say printing USB devices to devices, or USB devices.txt. Now it's not actually printing the USB devices to a file. Right now it's just printing it to the terminal. So that's where this redirect symbol would come in. And essentially it just redirects the output to a file. And it writes to that file the output. And as you notice, we had no files in our directory. But when we run this command, it'll create the file for us. So let's go ahead and give it a try. So we could do ls usb, and it's going to redirect to USB devices.txt. And then we'll do an echo here and say done listing USB devices. And that's how in our terminal, if you have a bunch of commands and some of them take a while, this is a good way to see where you're at in terms of running the prompt. So this is, like we said, this is listing the USB devices in our system. And first it's going to say that it's printing the devices to the file. It writes to the file. And then it says it's done. And we're going to do a similar thing with the lspci command with the PCI devices. So let's go ahead and type it out. We're printing out to the terminal, printing PCI devices to PCI devices.txt. And then we're going to redirect the lspci output to PCI devices.txt. And then we're going to echo again. We're going to say we're done. We're done listing PCI devices. Now, this is a pretty simple script. It makes use of some of the commands that we've learned today. It also shows how to redirect output to a text file. And if we're finished up, if there's nothing else you want to add to this file, or if you want to experiment, we could hit Control X. If you look here, there's this caret symbol. That is for control. So, if we wanted help, we could do Control G. If we wanted to cut, we could do Control K, etc. But we're going to do Control X because we're just finished right now. So we'll do Control X. And now you may notice it says Save Modified Buffer. So the buffer is like in-memory RAM. And that's where the file is right now. It's not saved on our file system, but it's loaded into the RAM. So once we save the buffer, the modified buffer, it basically is saying we're saving the file to our file system. And we do, so we're going to hit Y for yes. And then it says file name to write. Now you could change the name of the file here, and if you did, if you look here, it shows up. If you hit enter, it'll just complete it for you. But if you did, you could go back and say like devices script, and it'll ask you to confirm if you're trying to name it something else. But in this case, we're just wanting to write to this file which we're creating. So we're going to hit enter. All right, and that was a lot of work, but we very quickly did nano and we created a file. Now let's go ahead and do ls. And there's our script. Now let's go ahead and read our script to see what it comes out to in the prompt. See, and it says we're declaring the shell we're using, which is bash. We're listing the USB devices. We're printing the PCI devices out to the text file, and this is using the USB devices file. Now, if you want to run a bash script, there's a way to put it in the environment where you can just run it directly from your command line by typing it. And you can also use aliases to, maybe make it shortened or more readable. But in this case, because we are using the device script file, if we do ls here, we can see it. You're going to use bash to signify that you're using the bash shell. Then we're going to do device script .sh. And look at that, it echoed out the contents that we had mentioned. This is printing USB devices to USB devices.txt, which was the first echo command. And then it ran our other commands, and then it said done listing USB devices. It does the same here, it says that it's printing, and then it does the commands, and then it says done. Now how can we tell that the commands actually executed as we expected? Well, let's do ls and check our current directory. As you can see, now we're able to see the files that it created. Now, in order for us to know if it really had redirected the output from these commands to these files, we need to read the files, right? So let's do cat PCI devices.txt. And look at that, it has the PCI devices that we had listed from earlier in the episode. We went over what some of these could be and what some of this would mean, and we outputted that to this file. And now let's go ahead and do it again. Let's for clear first, and then we'll do cat USB devices.txt. And here are the USB devices. So you could see that we have our integrated VirtualBox USB tablet. We got the keyboard, we got the headset that we mentioned, so we're able to script the commands that we learned and make use of them. And like we mentioned, the whole point of this episode is for device configuration and management and learning what devices are connected to your system and troubleshooting them even. You could troubleshoot them with these commands that we provided. But also we've gone over a simple shell script that uses these commands and it redirects the output to files that we can then read, and you could make log files, and there's so much more you can do with like these scripts, and we're going to be going over these in future episodes. So I'm very excited to continue with you guys, and thank you for tuning into this episode. I hope you learned a lot about your system, about verifying the USB devices that are connected, the PCI devices, and just learning more about your system. And for example, if you're running WSL2 or VirtualBox and you have different configurations, you're going to be seeing different results here. So experiment and find out if you blacklist, if you don't want certain modules running, if you need a module, maybe if you're missing that graphics card and you're wondering, why is my graphics card not working on, or if you don't even know if it's working, you could always verify visually. Like we could see here that we're connected wired. We have a wired connection and it works. But, if it wasn't working, in order to troubleshoot if we even had the wired connection in the first place or the module for it, you would start using these commands and start to play around and see, okay, like, are our devices connected? Are they being registered? Do we have the right modules? And this is how you would go about administering a system. And this would even help you configure RAID setups and, initialize different devices. So thank you guys so much for tuning in. And I'm looking forward to seeing you guys in the next episode.